Welcome once again. This is Mr. E, and this is part 3 of lesson 2, finding the unique prime factorization of a whole number. So we're going to wrap up the rest of these problems. I hope that you went ahead and did them, and this is just a time when you're going to just check your answers. So let's go ahead and get started. So number 9, this is what we call an error analysis question. Melissa answered the following quiz question. Find the prime factorization of 216. Her answer and reasoning are below. And the question is, her answer is here. This is also part of her answer. And what you need to tell is, do you agree with her answer? And it's 2 parts. Do you also agree with the reasoning she used? And explain. Okay? If you haven't already done this, pause the video and answer it. If you have, just pause again and wait for the answer. Okay, here's a possible answer. Yours could be written differently, but it should contain the same element. So it's 2 parts to this question. I disagree with both her answer and her reasoning. The correct answer is 216 is 2 times 2 times 2 times 3 times 3 times 3. Also, her reasoning is incorrect. 9 is not a prime number, which is an example that not all odd numbers are prime. So, the key thing she got out of this question was, 1, 9 is not prime. So, if she would have continued this, she would have gotten 3 times 3. Also, her reasoning was 9 is prime because it's odd. That is not correct reasoning. All odd numbers are not prime. So again, there was 2 parts to this. Her answer and her reasoning. Her answer was wrong and her reasoning was wrong. All right, I think we're going to wrap up the next few problems, see where we are. Well, we'll go ahead. So again, hopefully you already did these. We need to simplify the fraction 87 93rds and 325 420ths. Now notice I never say 87 over 93 or 325 over 420. It's very important that we use mathematically correct language, but we'll talk about that more in upcoming videos. But right now, let's look at the prime factorization to simplify these fractions. 3 times 29 is 87, and 29 is a prime number, so we're going to stop there. And 3 times 31 is 93. Both those numbers are prime as well. So to simplify 87 93rds, we're going to divide by 3 because that's our common factor, and we get 29 to 31 or 29 31st. Let's use prime factorization to simplify number 10. Again, if I have a 5 in the ones place, I can divide by 5, and here I get 65. Another 5 in the ones place, I can divide by 5, I get 13. Prime, prime, prime. So our prime factorization of 325 is 5 times 5 times 13. And the prime factorization of 420, now you could divide by 10 if you like, because there's a 0 here, or you can divide by 5. I like to use prime numbers. 5 times 84 is 420. 84 divided by 2 is 42. 42 divided by 2 is 21. And 21 is 3 times 7. So I'm prime, 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 prime. What do I have in common? I'll write this backwards just so you can see it. So I have a 5, a 2, a 2, a 3, a 7, I believe that's it, 2, 2, 2 2s, 3, a 7, 5. Only thing I have in common here is a 5. So I'm going to simplify by 5. 325, 420 divided by 5, and I get 65/84. Okay. All right, that was it. And I think we're at about 5 minutes anyway. So that's how we find the unique prime factorization for a whole number. And in the next video, we're going to practice. So make sure you go through those problems and use the video just to check your answers. Talk to you soon.